Hi, I'm Rohit, and I made a console version of the popular game called the Connect4. So it's a two-player game, and basically players take turns to drop coins into a board, and this board has like spaces in it, and a player wins when he's able to connect four of those coins, either horizontally, vertically, or diagonally. So in our case, I have taken red and blue coins for each of the players. So player one always starts first, and he has the red coin, and in each step the player can choose into which column the player wants to drop the coin, and they'll win when the four of those coins connect horizontally, vertically, diagonally, and the match is draw when the board is fully filled. So yeah, so this the game loop that I've taken. So the game starts and player gives input. So either P1 or P2, they take turns, and after each input, we'll check for win condition, which is the four connecting coins, and the draw condition, which is the board is completely filled. And we'll repeat this until we have the winner or the match is draw, and we'll end the game. Okay, so this is my code base. We'll just play the game once for now. So this is a bunch of instruction and rules for playing the game, and this is the board that I've made to display. So first the player one starts and is asked to input any number between 1 and 7, which is corresponds to each of the columns. So let's say 3. You can see that the player one, since player one is red, he has dropped R into the third column, and player two will, which is blue, he'll drop B into the column. And basically, you can also stack one another, and the goal is to make it so that let's see, yeah. So in this case, player one has one because uh, R is diagonal, and there are four coins in the diagonal manner. So this is basically the game, and yeah. So for how I have approached this, making this problem, I have, let's say this is the board, right, and so this board has a bunch of cells. This is what in a table we'll call it cells. So I've also called it a cell, and the cell has either a space or or a blue, right, or a red or a space, right. Space, it will be less the gap. So basically we'll be dropping B and R's into this, and we'll check whether they connect in a the four of them connect like horizontally, vertically, and diagonally. So it could be this way, it could be this way, or something like that. So the point is to insert them in the correct manner and check them again and again whether each time they are connecting uh, to connecting in the same way, right? And okay, so this is my code base, and I have made it in a 3 file implementation. So this is my implementation file, and this is my header file, and finally this is my main file. So the main file has the blueprint for the game logic. So I'll be creating a game manager class. So I will be looking at the class later. So the main function, I'll be getting the input from the player, either it's a player one input or the player two input, and I'll insert the token. In this case, I have taken a token instead of a coin, and I'll be inserting it into the board, and then finally I'll be checking if the red has one or blue has one, or if it's a draw, and then I'll change turn, and I'll repeat this until we have got the win condition or the draw condition. So that's the entire thing in main. And we look at the header file. So I've made use of some macros here to define constants for my rows and columns, and finally the win count, which is the number of required consecutive coins to win. And I've used some enums here. So this is the game state enum, which specifies which game state we are currently in if it's playing. So playing in the sense the game is currently going on and neither of the users have won. And draw in the sense the whole board is filled, so it's draw and the game can stop now. And the enum for a red win and then blue win. So player 1 wins in red win and player 2 wins in blue win. And then we have a token here. So basically as I said here, I've taken these as cells. So the cells can either have a blue token or red token, or it can be empty. So I have implemented that in a enum. So the token can be empty or red or blue. So this is the cell class. So I'll be making objects of the cell class. So each cell here would be objects of this cell class, and the cell class has a token member. So this token can be empty or red or blue. And we can look at the constructor. Uh, so this is the cell implementation, and the constructor here is the token would be empty. So each when this board is created, when the cell is created, it will be set to empty. The token will be set to empty, and then have a get token function which is just a getter and then a setter. So that's the cell class. And then we'll move on to the game manager class. So the game manager class, okay. So this game manager class is the main this is where the main game logic runs. And I have a double pointer to a cell, which means that I'm able to create a 2D array with this. So we'll look at the constructor, game manager constructor, and this is where I have created a 2D array. So basically I've created pointers to a cell. So and for each pointers I have created the number of cells. So column cells and row cells. So I made use of the macros here for instead of defining the constant, so that it's easy to read. And yeah, so that's creating the 2D array for the board. And then I have an integer array. So it's integer pointer. I'll be creating a dynamic array with this. So this contents will contain it's basically let me show you what I'm doing here is I'll be creating a so I'll be creating a contents array. So it will have the same number of columns as the table, right? So just ignore this. So it will have the same number of columns as the table. And basically, whenever if I'm inserting into column 1, I'll increment it to 1. They'll all be initialized to 0 first when you're creating. So if I'm uh, inserting into column 2, it would get incremented. And if I'm like inserting into column 2 again, it would get it incremented to 2. So basically contents will contain the number of tokens that are present in each column, right? So that's what contents I have used for. And then bool p1 turn. So this is used to specify whether player 1 is playing or player 2 is playing. So if p1 turn is true, that means player 1 is turning. So in the game manager constructor, I set it to true because player 1 starts first. And then finally, I have the game state variable, which specifies which game state the game is currently. So it's a enum, and I have set the game state playing to playing. initially. So that's basically the constructor for game manager. And then this instructions is just a text uh, for user for specifying the instructions, right? And then is player one is getter function for player one p1 turn and change turn. So this is what I'll be using to change the player from player 1 to player 2 after each turn. So it will just flip the true or false. And yeah, and this game state setter and getter. And display board is for printing the board, as we saw here, right? And that's display board. Game manager destructor. So game manager destructor is for properly deallocating the space that I have allocated here in the constructor, and that's what I have done here. So that's game manager destructor. And then insert token. So insert token is the main thing. So player will only provide the column, right? So the player only provides a column. So I'll have to correctly uh, drop it in the correct column. So what I have done is I have taken the column, and what I know the max rows in the column. So in order to drop it correctly, in order to place it in the correct position, I'll just subtract the contents from the max rows. So in here, the max rows is 1, 2, 3, 4, 5, 6, right? And 6. So I have the contents is 4 now. And if I want to drop 1 into 5, like something into 5, I'll just 6 minus 5 and it would be 1, right? So, sorry, my bad. 6 minus 4, it would be 2. But since we are using index, right, 0 indexing, that 6 would be 5. So 5 minus 4, it would be 1. And I'll drop it into the first row. So that's how I approach this. Yeah, so this is where I'm placing the token. And then, yeah, I'll check win. So after each insertion, we have to check for the win condition. So the check win function is being used here. So I'll expand the check win. So this is a check win function which has three functions in itself. So I am checking horizontal, I'm checking vertical, and checking diagonal. So say, okay, say I'm having a blue here, right? Or let me go with the red, right? And in order to check for conditions, I have to do three things. So horizontal, vertical, and diagonal. So I could go checking every rows and every column and every diagonal, right? So that would be a lot of steps. So instead of that, since we now have the position of the current insertion, we'll just check the horizontal and vertical and diagonal from that. So I'll check this, 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 and this, right? So that's basically it. For horizontal, I am checking the current uh, horizontal row, and I'll have a count variable. And if I encounter the current R, then I'll increment the count to 1. And if I get it again, I'll increment it again. And then I have it again, I'll increment it again. And then I have it again, I'll increment it to 4. So when count reaches 4, I will like return true. And I have found that player 1 has 1. So that's about it. And if sometimes B is there, right? If B is there, then I know that uh, B is not R. So what I'll do is I'll reset count to 0. And then if I get uh, red again, I'll increment it to 1. So that's how I approach this. This same thing will be for vertical too. And let me, yeah, and for diagonal, what I've done is I've taken uh, diagonal left and diagonal right, and for each diagonal I have separated them into two halves. So this is one half, upper half, and this lower half. What I'll do is uh, I'll go in this way, so it's easier. uh, Basically I'll just go until I have found matches, and if I have not found the matches, then I'll stop there, and I'll continue with the lower half, and I'll continue again until I find 4, until 4 count is 4, and that will be the win condition. So that's what I have done here. So check win has check horizontal, check vertical, check diagonal. So this is the horizontal, and this is the vertical, and this is the diagonal. So diagonal, you can see there are like 4 sections. So this is for the section 1, which is left right diagonal. So this one, and section 2 is right left diagonal, which is this way. And each section has 2 halves. So this is the upper half, and then this is the lower half. Same thing here, upper half and lower half. So by the end of this, I'll be able to find if there's matching 4 consecutive tokens in the diagonal way, right? So that's check horizontal, check vertical, check diagonal, and yeah, that's basically inserting. So one condition for inserting is, yeah, when the contents is equal to the max rows. So that's when we know that column is full. So we shouldn't allow inserting into that column. So I'll just return false, and player will have to input into another column. So that's that. And from check win will return true or false. So if it's true, right, if it's true, and if p1 turn is true, then that means player 1 wins, so red win. And if it's true and player 1 turn is false, that means blue wins. And yeah, so I'll return true. Yeah, so after game set is set to red win or blue win, we'll go back to main. So where's insert, and here's insert, right? So I'm inserting, and if it's false, that which means the column is full, that means I'll display the board, and I'll just continue. I'll just skip all this checking for win conditions. I'll go to the next iteration, and I'll ask input for the same player, right? And if if the insertion is successful, we'll continue. I'll just check for draw condition first, which is right here. So basically I'll check each I'll check the contents, and if all contents have max rows, so that means I'll set it to draw, else I'll return. Okay, and that's basically it. So I'll check draw, and I'll check the game state. If it's not playing, I'll check who won. So if it was red, if it was blue, and if it was draw, I'll just uh, break the loop. And yeah, that's the end of the program. uh, so thanks for watching this video. Mm, I'm open to suggestions or any better ways to solve this problem. Uh, Thank you. Have a nice day.